Hello, Mr. Claudia here, and today we're going to learn how to solve trig equations. Now, remember, an equation is a mathematical expression with an equal sign and one unknown variable, one unknown expression. We've learned over the course of our high school career how to solve many different types of equations. So let's review a few of these solution methods. The first type of equation is a linear equation. You would have learned this in grade 9. How do I figure out what x value makes this statement true? Well, what your math teacher would have shown you back in grade 9 is you want to undo order of operations backwards and you want to get the x by itself. So I'm going to divide both sides. I'm going to write this in red. I'm going to divide both sides by 5. And now I end up with the 5's cancel out, so I end up with x is equal to 3. So that was the easiest type of equation. You just need to isolate for x. Then we taught you about quadratic equations. Now, unfortunately, quadratic equations, we can't just isolate like this. We know there's a value of x that makes this true. There are actually two values of x. The only way to solve a quadratic equation is by factoring or the quadratic formula. Now, I don't like the quadratic formula very much, so I'm going to factor. Let's see if I can figure this out. 7 times 4 gives me 28, so this is -7 and -4. Perfect. So now I have two solutions, x equals 7, x is equal to 4. So here in this case, what I had to do is I had to isolate for x. In this case, I had to factor or use the quadratic formula if need be. Then we taught you in this course some more difficult equations. This is a exponential equation, meaning the unknown is in the exponent. There are a few different ways of solving this equation. One would be to log both sides. You could choose a base that is favorable to you, or you could use the same basis kind of strategy. You could rewrite this as 4 to the power of 3, right, is 64. So therefore, x is equal to 3. So you would same base technique or log both sides. Log both sides is probably what you're more familiar with, right? But it's very useful if you have a calculator. We also taught you about logarithmic expressions or logarithmic equations. So what x value makes this true? Well, an easy way of solving this is to rewrite it as an exponent. So this would be, remember there's an imaginary base e here. You can rewrite as e to the power of 5 is equal to x. So that was rewrite as an exponent, or as an exponential equation. All of these solution methods give us the x value that makes the original statement true. Now let's look at trig equations. When you say sine of what gives me 1 over root 2? Well, you might remember, I can figure this out. I can find the angle. What I learned from my geometry chapter is I just need to take the inverse sine of this. Or you might call it the arc sine. That's another way we could write it. Okay, so let me use my calculator to do this. Shift sine 1 divided by root 2. And I get an answer 0. Oh, sorry, I'm in radians mode. I keep doing this. Okay, 1 divided by root 2. I'm going to take the sine of that answer. Oh, shoot. Shift sine of that answer. And that gives me 45 degrees. Oh, cool. There we go. So the angle that makes this true is 45 degrees. However, so this is how we solve all these other equations. There is a problem with solving a trig equation with a calculator like this. The calculator's weakness is it only gives you one solution. So I'm going to put a big asterisk there. Consider that in our last lesson with the Castro, we determined that sine 45 is the same as sine 135 is equal to negative sine 225, sine 45. There's an infinite number of angles that will give us this ratio, 1 over root 2. for that reason, just using the calculator is only going to give you one possible solution. So we have to learn a method for dealing with trig equations where we are not so dependent on the calculator. There are an infinite number of solutions. So that's my star. So we must use our knowledge of cast rule and the unit circle as well as the domain of the question to find the correct solution. Or what's more likely, to find the correct solutions. There's probably more than one. So sine 45 or 45 degrees is not incorrect for this statement, but it depends on what the angle is, or what the domain is. If the domain was between say 0 and 360 degrees, this is only half correct. There's another possible answer that makes it true. In much the same way here, if you just said x equals 7 is the answer, that's true, but that's not all of the possible values of x that make the statement true. So let's do a question. Let's do a trig equation. So I have 2 sine x minus 1 equals 0. Look at that. It's an equation with one unknown, so I should be able to solve it. And then I've been given a domain. So the first thing I want to do is get this to the point where it looks like this, where I have the sine and of some variable all by itself. So I'm going to bring the 1 to the other side, so I end up with 2 sine x is equal to 1. I'm going to divide both sides by 2, so I end up with sine x is equal to 1 over 2. Okay, at this point now, I'm going to be working backwards. I mean, if you can remember our lesson from yesterday where we were looking with cast rule and unit circle, here I was given the angle and I wanted to figure out the ratio. In this case, I'm going backwards. I've been given the ratio, so then I need to figure out the angle. So I'm going to take the ratio, figure out the acute angle, then figure out, based on whether it's positive or negative, what the kind of angle, the terminal arm is, to give me that answer. So let's just write that out here. Think. Which angle gives us this trig ratio? Okay, well, half. That sounds familiar. That sounds like it comes from the special triangle, that second special triangle, the 1, 2, 3. So let me draw that here. Hopefully by now you're getting better at drawing it. If you remember 1, 2, 3, well, this is the shortest side, this is the 2, and this is root 3. And then the angle should be 60, but we're looking at radians, so this is going to actually be pi by 3, and this is pi by 6. Okay, now I want to know, okay, so which angle gives us a trig ratio, sine of 1 over 2? Well, that would be opposite 1 over 2. Oh, so it's this angle, right? Is opposite is 1 over 2. So we know that sine pi by 6 is equal to 1 over 2. So therefore we know the related angle, or the acute friend. The related angle is pi by 6. That's technically one possible solution for this expression. However, there could be more. And look, there's a restriction on the domain from 0 to 2 pi. So I can actually do a full revolution. So there'll be at least one other solution. So now I am just going to continue working backwards with my cast rule. So we know that one possible solution is if the terminal arm is right here. I didn't draw it very well, but this is pi by 6, right? That's one solution. Remember, this is cast rule. So one place where, because we want sine of positive 1 over 2, Well, one place where sine is positive is in this quadrant. So there's pi by 6, that's an easy one. Where else is sine negative? Or sorry, is sine positive? Oh, sine's positive in this quadrant. So I would have the exact same acute angle, acute friend, right here, which is pi by 6. Now I just need to figure out, okay, so what is the angle that gives me that? Well, to get, this to be pi by 6, this is 6 pi by 6, so this has to be 5 pi by 6. So let me write this out. For x is between 0 and 2 pi, which is a full revolution, there are 2 positions on the unit circle where sine pi by 6 is equal to half. X is equal to pi by 6 and x is equal to 5 pi by 6. You might be thinking, well, what about down here? Like, what if I had the one down here? Well, no, because the sign is negative, and we know sine is positive here. What if we had it here? Well, sine is negative again. And you might be thinking, what if I did a full revolution and came back to here? Well, that would be 2 pi plus pi over 6, which is beyond the range of my, my domain there. So there are only 2 solutions. So we can see that if I had done this with a calculator, I only would have gotten one answer. It wouldn't have been a correct solution. You have to use unit circle. Unit circle takes all your knowledge of this kind of unique situation with the periodic functions and allows you to find all the correct answers. I will just show a pet peeve also that I see sometimes students write on their test. They say, oh, look, sine x is equal to half. And then, this is horrible, the student says, oh, okay, well, I'm just going to divide by sine. And then they have, I don't know what they have, x is equal to something, something, something. Anyways, never do that, right? No. No. Right? You can't just divide out the sign. If you want to undo a sign, you can use the inverse sign, sine to the -1, but don't like divide a sign. In much the same way that you can't just divide by ln.
In this question, we're asked to find the exact solutions for cos 2x equals 1 over square root 2, for 0 is less than or equal to x is less than or equal to 360. Well, first we can notice that the argument for cos is 2x and not x. So we should look at the bounds for 2x. If we multiply both 0 and 360 by 2, we'll get that the bounds are 0 is less than or equal to 2x is less than or equal to 720. What this means is that there's going to be more solutions than we're used to. In fact, for every value that we find for 2x that between 0 and 360, there's going to be another value after one full revolution. And you'll see what I mean as we keep doing the question. So let's disregard the cos 2x. Let's just think of what value of cos gives us 1 over square root 2. Well, if we consider one of our special triangles, specifically the 1, 1 square root 2 triangle, we see that a value of 45 gives cos 45 equals 1 over square root 2. So we can say that the related angle is 45 degrees, which we can draw on our axis. Therefore, if we want to find x, we're going to set 2x equal to 45 degrees. And then when we solve for x, we get the first value of x is 22.5 degrees. But that's only one angle. Remember when I said that if you take a value of 2x between 0 and 360, we can add one more revolution to get another angle. So what that means is we get this angle 45, and if we add 360 again, we're going to be in the exact same spot, but that's still within our bounds of 0 and 720 degrees. So if we take our x and our 2x and add 360 degrees, we're going to get 2x equals 405 degrees. And if we divide and solve for x2, we'll get 202.5 degrees. Okay? But we know that by cast rule, there is another angle that satisfies this equation, such that cos is positive 1 over square root 2. The second angle lies in quadrant 4 and is given by 360 minus the related angle, which is 315 degrees. So if we draw 315 degrees, we see that we end up in the fourth quadrant with a related angle of 45 degrees. We see that we can solve for x. That gives us 2x equals 315 degrees. Divide by 2 on each side, and we'll get 157.5 degrees. And again, we can do what we did before in that we take this 315 degrees and do one full revolution around to come back to 315. That gives us 675 degrees when we add 315 plus 360. That equals 2x, and if we divide by 2 on each side, we'll get that the last value of x is 337.5 degrees. Therefore, the solutions are x equals 22.5 degrees, 157.5 degrees, 202.5 degrees, and 337.5 degrees.
Next question. Again, what are we doing here? We're solving trig questions, or trig equations. So here I have sine squared minus sine x minus 2 is equal to 0, or for a balance between 0 and 2 pi. Ooh, difficult. I hope you can see what I see here. I hope you can see that this looks like something squared, like triangle squared, minus something equals 2. Or if you don't like triangles, this is a squared minus a equals 2. Which, if I rearrange, I get a squared minus a minus 2 is equal to 0. Which is a quadratic, right? And I know how to factor. I know how to solve quadratics. I have to factor. This would be minus 2 plus 1. So that's sort of kind of the caveat of this question. You have to kind of look at it and see a quadratic. You could do a substitution if you want, but really once you've kind of figured out the question, you should be able to write it using the trig ratios again. Okay, so now we have a quadratic. This quadratic, I basically factored it and I got this expression, but I'm not done. Remember, I need to know what x makes this true. Now, because when we do a quadratic, we factor it, basically this statement is true if this is equal to 0 or this is equal to 0. So in this case, sine x minus 2 is equal to 0, or sine x is equal to 2. Is there a solution to that? I mean, let me try using my calculator. Shift sine 2. Math error. Why is there a math error there? Well, there's a math error and there's no solution because sine can never be more than 1, right? If you think about the sine wave, we're going to get into graphing sine later, but you probably remember from a previous course, the sine curve, which goes up and down like that, it oscillates between positive 1 and negative 1. It never exceeds 1. So to have a sine of anything be 2 is impossible. So there we go. Sine x is between positive and negative 1. So our only hope is this other factor. The statement is true if sine x plus 1 is equal to 0, so if sine x is equal to negative 1. You could, again, do this with your calculator, but I'll show you without. Quick way to remember this. Remember, sine has to do with your y value. So we want to know where the y value is negative 1. We want to know where the terminal arm is negative 1. And that happens to be at all the way around like this, 3/4 of the way around the circle, 3 pi by 2. So x is equal to 3 pi by 2. If you wanted to, you could have gone shift sine negative 1. What are your answers going to be? Negative 90. Got to do some thinking if you're going to use your calculator. That means that you've gone this way. But negative 90 is not a valid answer, so that would be the terminal arm location. but negative 90 is not a valid answer. The valid answer has to be between 0 and 2 pi or 360. So that's why I had to use 270 or 3 pi by 2. Neat. Okay, let's look at one more question. Now they're getting really scary. Find the exact solutions of root 3 sine equals cos x for x's between negative 80 and positive 180. So, well, I've got a problem here because all of the other questions I eventually got to sine x equals something or cos x equals something, sine x equals something. But the problem here is I have a sine and a cos. This stresses me out because I don't know how I'm going to eventually solve it using the unit circle. The strategy here is you're going to use your identities, your trig identities. Now you really only know 2 so far. You know sine squared plus cos squared equals 1, and you know sine over cos. That's actually what I'm going to recommend you do, is you divide both sides by cos. Watch what will happen now. You're going to end up with root 3 sine x over cos x equals 1. Now I do want to get rid of the root 3, so I'm going to divide both sides by root 3. So now I end up with sine x over cos x is equal to 1 over root 3. And there's my trig identity. Tan x is equal to 1 over root 3. So that's a remember, so far you only know 2 trig identities. In IB, you really only have a few more to learn. There aren't that many options. Sine divided by cos is always going to be a nice one. It works out. So now we have the situation where I know the ratio. I need to figure out the angle. So you have to kind of do this thinking where you go backwards. Think about it. Which angle gives this ratio? Well, 1 over root 3, that sounds a lot like the 1, 2, 3 triangle. Let me do a quick sketch of it over here. Now we're using degrees this time, so this is 60, this is 30, this is 1, 2, root 3, make sure you draw it correctly. So tan of what gives me 1 over root 3? So opposite over adjacent, so tan of 30 degrees gives me 1 over root 3. Again, you could have done this with your calculator, but you likely don't have your calculator here. 1 divided by square root of 3, shift, tan, answer 30 degrees. But you probably don't have your calculator. So too bad. So now we know the related angle, or the acute friend, is 30 degrees. So now it's just a matter of figuring out what are my possible solutions to this. I mean, we've done all the work. Now I just have to figure out, based on the bounds, what are my answers. It's from negative 80 to negative 180 to positive 180. So if this is my unit circle, when is tan positive? Well, tan is positive in this quadrant, so that would be a related angle of 30, means I've drawn an arm like this, and it comes down like this. And this angle is 30. So that's one possible arm. Remember, there's always 2. So where's the second one? Well, it's over on this side. When that angle's 30. Now, the question is saying, where are the solutions between negative 180 and positive 180? Well, in the positive 180, which goes from this arm all the way over to here, there's only one solution, and that would be x is equal to 30 degrees. The other solution, I can't use this arm going this direction, because that would be 210. But I can go in the opposite direction, which is, what is that? Negative 180, so negative 150. So you can see how you wouldn't have gotten that without using a drawing and your understanding of the unit circle. Great. So that is how you solve trig equations. Your homework for today is page 455. number 1 to 4, and page 456, number 1 to 3. Good luck with that, and we'll see you next time.